Well, and from the gold beads, we move slightly for the abstraction. And this is called the stamp game. And it's used in the early childhood class as well as the elementary class. But instead of having beads, we're moving to symbols. But they actually lay out, 2 units, 5 tens, 3, and so they're physically still doing the using materials, but it's just a little step towards abstraction. And again, they can do all of the operations with this material.
And then, so one important thing is the continuity in the classroom. So the units are green and then the tens are blue, and the hundreds are red, which are the same colors they first started using.
And then units of thousands, so tens of
thousands would be blue, hundreds of thousands would be red, units of millions green, and they start to recognize that, they can verbalize that. And then this would be the next step in abstraction, where you can compose the same kinds of numbers, and this would be 4 units, 3 tens. Put my glasses on so I can tell. 600s and 4 units of thousands, and then I can either add to or take away or do multiples of. That's how this material works. It's very similar to an abacus. The only thing you can't do with this material is divide, because you can't physically share them, but you can do all the other operations with this. This would be the small bead frame, and the large bead frame goes up to the units of millions. And this one would be the bigger. This is 1 unit. This is 1 ten. You all know that 10 units make 1 ten. And you can count them later if you'd like to. Just to make sure. This is 100. And we've had lots of experience knowing that 10 tens make 100. And this is 1,000. I have something new to show you. This is 10,000. And they do an awe. This is 100,000. More. Do you need help? And this
Whoa.
is 1 million.
This is 1 unit. You all have worked with fractions. What's this? This is 1/10. And if this is 1/10, and usually someone can come up with it, this is 100, and so on, all the way down to 1/1,000,000. And we introduce it first with fractions, which they've worked with fractions at this point. But that's how we introduce decimals. That's how we move into decimals from fractions.
So when you're not working with the stationary system of numbers, when you're working with a metric system, it's so much simpler for kids to get that because it's not abstract like it is when you're doing it traditional stuff.
The red and blue rods, the long one is a meter stick.
Mm-hmm.
That's just another little fun thing.
Another big fun thing.
Yeah, Montessori is an experience. It's not just knowing. You experience the millions.
Right, and you feel this, and they carry it. And you experience that.
It sort of has a lifelong joy of learning.
Yes.
It's not so important to me whether they'll be maths experts or doctors or whatever. As long as they enjoy the process of learning and they'll take it with them for whole life.
Well, then they'll figure everything else out. I think.
Right.
Mm-hmm.
If they learn how to learn and experience that joy. I'll just
Me neither. Must be covered up in the classroom.
That's really cool.
I think our job is to lead them to where they can find the information more than just telling them the answer.
Mm-hmm.
In the upper L class, they don't come up and say, Stephanie, what does this word mean? And to me, it's my best friend. And I go and I get the dictionary. This is dictionary. This is your new friend. You know, or just about anything. You know, if you just kind of point them in the direction and then they're able to find it themselves, it's so much more rewarding than just kind of, oh, the answer to this, of course this. And then they, you know, if you keep giving them the answer, then they're going to expect that you'll always give them the answer. So if you let them find it on their own, it's like that.
Mm-hmm.
So we've been showing you how to multiply or numbers with a single-digit multiplier, but then this material helps you be able to multiply with a 2 and 3 and even a 4-digit multiplier. So you're even getting into much larger numbers than this. And I've already set up the two parts of this problem, but I have here in the same color combinations that we've already been talking about, 2,000s, 800s, 410s, and 6 units, and I'm multiplying times 54. So I have 6 units 4 times. 6 units 4 times is 24. I have 4 tens 4 times is 16 plus 2, 18 tens. I have 800s 4 times plus 1 is 33 hundredths. And I have 2,000s 4 times plus 3 is 11 thousandths. And that's my first partial product, which I would record here. I'm not going to do all the parts right now, but I have 5. This is now tens because I'm in the tens place, so there are no units. So I have 6 tens 5 times, which would be 330 tens. 4 5 times 2 5 times plus 4 is 14 tens of thousands. Then, you've done this before, you're combining your tens with your tens, your hundreds with your hundreds, your units of thousands with your units of thousands, tens of thousands with tens of thousands, and hundreds of thousands. So it's all those steps, but it's in a concrete way. Then you've done the 2 partial products and you get the sum. So these I don't have to add anything. 3 plus 3 is 6. 2 plus 1 is 3. 4 plus 1 is 5. And there I have my whole product. Isn't that crazy? And the kids can do it faster than I can. I'm like, wait, and the thing is, someone thought all this, created all this to make math concrete and help children learn. And if you're impressed with that, come to our class and let a child show you test tube division. Long division, abstractly, we have actual concrete way that they see it and see all the steps and why you do it that way. It's my favorite material. I'll show you one more thing, and then we just sometimes have to have a parent